As you can see from our previous examples, grounds are vital to the operation of the electrical system. And systems whose operation is based on milliamp signals, like the ECM, PCM, SIR, and ABS systems, are extra sensitive to their ground circuits and connections. What would seem to be a minor amount of resistance in a ground circuit, caused by things such as corrosion in paint, can have a detrimental effect on these circuits. In effect, it's like having a resistor in the circuit. Consider this. The level of voltage and amperage flow in a particular circuit helps determine the factory calibration of electronic sensors. In turn, the resistance in a ground circuit has a direct bearing on the level of voltage that's available for that circuit. If the resistance in the ground circuit rises above a predetermined level, it lowers the voltage to the sensors in the circuit. In effect, this changes the calibration of the sensors, and everything goes out the window. A ground circuit problem can usually be identified by strange, seemingly unrelated problems like flashing lights along with intermittent operation of various systems and components. Two different tests can check for this problem. The CAM's ground credibility test will tell if the ground is good or not. Or use a DVOM to perform a voltage drop test. Now, I know what you're thinking. If you want to check resistance, why not use the ohm meter function of the DVOM? Well, an ohm meter provides very little current during a resistance test, far less than when the circuit is actually operating. And this can lead to inaccurate results. However, a voltage drop test checks the ground circuit with its normal current load. And that will show the exact voltage that's taken up by resistance at a ground connection. Ground G100 is especially critical because it provides a ground path for all components that use an ECM, PCM, or EBTCM ground path. A ground that offers too much resistance will reduce circuit voltage, power that's needed to operate components and allow accurate sensor values. Also, keep in mind that you can't test a ground for looseness by trying to wiggle it with your hand, unless it's really loose. If you suspect a loose ground, tighten it with a torque wrench. Now I'd like to talk to you about one other item: clean and dirty grounds. A clean ground is one that has only minor changes in the current that flows through it. A clean ground is essential for proper operation of electronic components that operate on low current, like the ECM, PCM, and ABS system. A dirty ground is used for relatively high-powered components like power windows, power door locks, and headlamps. Since these components use more current than electronic components, they have a greater swing in the current flow through their ground circuits. Problems arise when the ground from a high amperage circuit is spliced into a low amperage circuit. The fluctuations in the current flowing through the high amperage ground circuit causes the current flowing through the low amperage ground circuit to change. And changes in current flow through the ground circuit can cause sensor voltage values to change dramatically.